Well, how many of you have ever wondered how to add or subtract Roman numerals? Let's give it a go. Right, the Romans had to be able to do that. They didn't have our beautiful Arabic decimal number system yet. So they needed a way to add these or subtract these without first converting it to our decimal system and then converting the answer back. That's sort of a cheat way we do today if we want to be funny and play around with Roman numerals. But let's see how we actually do that. And we will not convert until we get to the end, just to see if we've done it right. So we'll use just these values, even if you don't know what any of that means. We'll just use these values, you do the algorithm, get to the end, and then see if it makes sense if we convert these into our own decimals. We've got our handy little chart here on the right, showing what each letter represents. M 1000 all the way down to I being 1. Okay, so step 1. We want to change any additive notation, any subtractive notation into additive. What do I mean by that? A number like 5i. Well, that is additive because we have the v and then we add the I and then we add that I. So we get 7, 5 plus 1 plus 1. Right? IV, that would be subtractive because we don't say 1 plus 5. In this case, we say 1 less than 5, which is 4. So this is the difference between additive and subtractive notation. And how you can spot that is if you see a lower valued letter in front of a higher value letter. That would be subtractive notation. So let's check at the top one first, our top number. So MDCCXXI, MDCCXXI. There is nothing wrong with that. That's already an additive notation going all the way from most value to least value in order. So that one we can just rewrite. So that is M, D, 2 C's, 2 X's, 2 I's. Plus, then this one, we've got M, C, X, but XL, here is an X in front of an L. So that's a lower value thing in front of a higher value thing. So there we have a subtractive notation part. So the M and the C, that's fine, we can write that. But XL, what does XL mean? It means 10 less than 50, so it's 40. That means 1x less than 5 x's. That gives us 4 x's. So that'll be x, 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 4 x's. And then V triple I, V triple I. Alright, so now that we've rewritten it in additive notation, we want to just write all of this next to each other. So let's go M, D, C, C, X, X, I, I. That's the top part. Then we do the lower part. M, C. Then we have 4 X's. 1, 2, 3, 4. A V and 3 I's. Okay. Now from this step onwards, well, let's do one more step of simplification and just write this in order now. Highest to lowest. So we look at M's first, the highest number. There are 2 of them. So we go MM. Then we look at the D's. How many D's are there? 1. We can do the same for C's. 1, 2, 3. So that's C, C, C. Then L. No L's. Then X's. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 X's. The V's. 1 V. I's. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Brilliant. Everything in order. Now we can start. We start from the right and we start contracting. So if there are 5 I's, it'll turn into a V. Okay, so we've got M, M, D, C, 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 6 X's, 2, 3, 4, 5, 6, V, and then those 5 I's become another V. Alright, and now we continue this algorithm. We look again from the right. So M, M, D, C, 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 6 X's, 1, 2, 3, 4, 5, 6. And then these 2 V's together, what do they become? 2 V's give us an X. 2 V's give us an X. Perfect. Let's continue. So M, M, D, C, C, C. Now we have 1, 2, 3, 4, 5, 6, 7 X's. So 5 of those X's can give us an L. So let's do that here. So these 5 X's gives us an L. And we're left with 2 more X's. Okay, Anything else we can do? 2x's becoming nothing. So we need at least 5 of something to turn into something else. So that's fine. We're done. Only thing we have to look at now is there anything that we can change back into subtractive notation to make the answer just look a little bit smaller, to take up less character space? And that we'll know, well, no, we don't see anything that we can do there. So this will be our final answer unless I missed something. Right, so let's quickly check the actual numbers. Let's check the actual numbers. So this number, we've got 1,500, 1,500, 600, 700, and 10, 20, 22. 1,722. Okay, and one just below, 1,100, 1,140, 45, 6, 7, 8. 1,148. Okay, and let's check this number. So 1,000, 2,000, 2,500, 600, 700, 800, 850, 870. So that's 2,000, 5, 6, 7, 800, 2,870. Okay, now let's check if it works out in our decimal notation. Let's use another color for this. I think green would work. So let's check if we do our system that we learn at school with our nice beautiful decimal system. What do we get? So we get 2 plus 8 is 10, 2 plus 4 is 6. Well, that's interesting. 7 plus 1 is 8, and 2 plus 2, 1 plus 1 is 2. Okay, the 10, that should not be a 6. That should be, because of carryover, this gives us 1 plus 3 is 1 plus 2 is 3, plus 4 is 7. 2870, which is exactly what we got here. Beautiful. We see this system is slightly more efficient than the Roman numeral system. So many less characters than the Roman one. Okay, now let's do division, and I promise we won't look at multiplication or division. Let's just do minus, subtraction. Okay, let's do this whole one in blue. Okay, so we'll have the same first step, converting everything into additive notation. So the first one we saw, that's fine. We know that's perfect in additive notation already. Now the second one we saw, that'll turn into this one. We're not going to go through all those steps again. I'm just going to write that down. So 4x's v I. Okay, now what do we do from here? Well, now we don't put them all together, but we start cancelling out things that are the same, which is pretty much what subtraction means, right? If you have something and you take it away, it's not there anymore. Sounds pretty simple, but that's what it is. Okay, so these two, so 2 of these i's can cancel with 2 of those i's. 2 of these x's can cancel with 2 of those x's. 1 of this c can cancel with that c, and the 2 m's can also cancel. Alright, so what do we have left? We've got on the left hand side dc, yep, and on the right hand side we've got xx vi, xxvi. Okay, so the problem is there's nothing left to cancel, but we can expand some of these ones. So let's expand. Let's say we keep the d, and the c we can write it as 10x's if we like. I'm just going to, for saving a little bit of space, I'm going to write it as an L with 5 x's. So c I'm going to write as an L with 5 x's. So minus xxvi. Okay, so what can we cancel now? Well, we can cancel 2 of these x's with 2 of those x's. What are we left with? dl xxx minus vi. And again, we can change one of these x's into a v and 5 i's. So dlxx, and now this x I'm going to change into v, 1, 2, 3, 4, 5 minus vi, and we can cancel the v and the v, we can cancel the I and the I. So finally we're left with dlxx and 1, 2, 3, 4 i's. 1, 2, 3, 4. So that's fine, but we can change these 4 things into subtractive notation. So we can say our final answer should be D, L, X, X, and then this, the 4 i's could be written as IV. And there we go. That's it. That's the final answer. Let's maybe just for completeness sake just check out the actual values in decimal notation. So we know that was 1722. We know this was 1148, exactly the same as on the left. I used the same numbers. So what does this give us? So this is 500. This is 50, so 550, 60, 70, 574. 574. And let's do the subtraction. Primary school style. 117, no, I can't even write. 1722 minus 1148. Okay, so the 2 cannot subtract, we have to go borrow, so that becomes a 12, and this becomes a 1. Okay, so the 12 minus 8 is 4. 1 minus 4, we can't do that, so we have to go borrow again. So this becomes an 11, and this becomes a 6. So 11 minus 4 is 7. 6 minus 1 is 5. 1 minus 1 is nothing. There we have our answer, exactly the same. So this is how we add and subtract Roman numerals. This is the algorithm we use. Feel free to go try it. Let me know if you have any questions, and maybe in the next video, maybe we'll look at some multiplication. I'm going to warn you though, multiplication is quite a lot more complex, and not even all numbers can be multiplied using the Roman system. Very interesting. Let me know what you thought, and if you have any other questions on Roman numerals in general, let me know. Thanks.